In this video, I'm just going to run through a couple of examples of balancing oxidation reduction reactions by the half reaction method that's outlined in your text. And these are the steps that are in your book in section 4.2 for balancing oxidation reduction reactions by this, what we call half reaction method. And I posted a couple of examples on EdgeCat that you should give a try. And I just want to run through a couple of these. I'm going to do the first two, and then I'd like you to try and do the others. For balancing oxidation reduction reactions can be very complex. They can have 3 or 4 or 5 different reactants and the same number of products. And they're really hard to balance by inspection. So instead, what we usually do is we look at a chemical reaction, for example, that maybe has potassium iodide and sodium chlorate or sodium perchlorate reacting to make triiodide and chloride ions and sodium ions and potassium ions. And we eliminate out all the spectators. Okay, so we end up with just the substances that are being oxidized and the substances that are being reduced. So this is actually going to end up being an ionic equation or a net ionic equation. But keep in mind, for example, if I give you something in an equation like I minus doesn't exist all by itself. In order to get I minus ions in solution, I have to dissolve some compound that's got I minus in it. So this probably came from something like sodium iodide or potassium iodide, but the sodium and potassium ions are spectators, so we can ignore those. So to balance this, I'm just going to break it into 2 what we call half reactions, and a half reaction for the oxidation and a half reaction for the reduction. And I'm just going to keep like things together. So my 2 half reactions for this one is just going to be the I minus changing into I3 minus. And the other half reaction are the 2 things that have chlorine in them. ClO minus going to Cl minus. After I write those 2 half reactions, I have to balance each one of them for atoms and charge. And that's what the next 3 or 4 steps in that procedure talk about. So let's just look at this first one. First of all, there's 3 iodines on the right, and there's only 1 on the left. So I need to put a 3 in front of that to balance the iodines. Now, the next thing I want to balance is oxygens, if there are any. And I balance oxygens with water, but there are no oxygens in this. And then after I balance that, I balance hydrogens with H+. Well, there's no H pluses in this first equation either, or no hydrogens. So the last thing I have to do is I have to balance the charge. And if I look at the charge on this, this is 3 I minus 1 ions, changing into 1 I3 minus ion. So the charge on the left on this is -3. Charge on the right is -1. I have to make it the same on both sides, and I do that with electrons. And electrons, recall, are negatively charged. So I'm going to add 2 electrons to this side of this half reaction. That makes it -3 on this side and makes it -3 on this side, and that balances the charge. All right, so that half reaction is balanced. Now I'm going to do the same thing for the next one. I've got 1 chlorine, I've got 1 chlorine. I have an oxygen on the left in this one, and it says that I should balance oxygens by adding water. So I'm going to add 2 H2Os to this side of the equation. I'm sorry, not 2 H2Os, just H2O. 1 H2O. And that will make an oxygen on both sides. Then it says to balance hydrogens with H+ ions. Well, I've got 2 hydrogen ions here, or 2 hydrogen atoms. So I need to put 2 H plus ions on this side of this equation. So now it's balanced for atoms. I've got the same number of atoms of both things on both sides. So now I have to balance the charge. And on the left side, I've got a 2 plus charge and a -1 charge. So overall, it's +1 on this side. On this side, it's -1 and neutral. So I need to make it -1 on both sides. So I have to add 2 electrons to this side of that equation. And if you get to this point where you're adding electrons in, the electrons have to be given off by one of the reactions and used up by the other. Or in other words, one of these has to be an oxidation, where something loses electrons. The other is a reduction, where something gains electrons. If your electrons end up on the same side of both equations, you're putting one of them in the wrong side. All right, the next thing we do is multiply through these equations so that the number of electrons lost and the number of electrons gained are the same. Well, in this one, I don't have to do anything because this one gives off 2 electrons. This one uses up 2 electrons. So they're already the same. And then the last step is I add the equations and eliminate anything that shows up on both sides. Well, the one thing that ends up on both sides of this is the 2 electrons, so I can cancel that. And that's pretty much it as far as canceling goes. So now I just gather everything on the left and gather everything on the right for my overall reaction. So I end up with 2H plus ClO minus plus 3 I minuses, changing into Cl minus plus I3 minus plus H2O. The last thing we do is check and make sure that this is actually balanced now for both atoms and charge on both sides. So on the left, I've got 2 H's. On the right, I've got 2 H's. On the left, I have 1 chlorine. On the right, I have 1 chlorine. On the left, I have 1 oxygen. On the right, I have 1 oxygen. And on the left, I have 3 I's. And on the right, I have 3 I's. So it's balanced for atoms. Now check the charge. I've got 2 pluses, a minus, and 3 minuses. So this is overall -2 on the left. And I've got a -1 charge on the Cl and a -1 charge on the I3. So it's -2 on the right. So that's my answer. That's my balanced equation for both atoms and charge. Now, the next one is a little bit harder. And you might want to do these on a separate page, not necessarily try to squeeze them in onto this page, because I'm going to end up writing a couple of things for this one. But it's the same process. I'm going to split it into 2 half reactions. I'm going to balance each half reaction, and then I'm going to add them together. So first of all, splitting it into 2 half reactions. I go AS2O3 changes to H3ASO4. Those are the 2 things that have arsenic in them. The other 2 things have nitrogen, so I'm going to go NO3 minus goes to NO. Make sure that you put the charges on these too. The charges are important when we are balancing for charge with electrons. All right, so those are my 2 half reactions. The next step is to balance each one of those. First for atoms, and then for charge. So first of all, I've got 2 arsenics here, and I've only got 1 here. So I know I'm going to need a 2 in front of this. That balances the arsenic. The next thing I should balance is oxygen. And there are 3 oxygens here, and there are 8 of them over here. So that means that I'm short 5 oxygens on the left. So I need 5 H2Os on the left-hand side of this equation. The next thing is to balance hydrogens with H pluses. And this one's a little bit tricky because there's actually already hydrogens on both sides. But there are 10 hydrogens in 5 H2Os. There are 6 hydrogens in this molecule. So I need 4 more. So I'm going to add 4 H pluses to this side. Okay. Next step is I've got a balance for atoms. Now I have to balance it for charge. And if I look on the left, both of these are neutral, so there's no charge. Over here, there's a +4 charge because of the 4 H pluses. I need to make it the same on both sides with electrons. So I need to add 4 electrons to the right-hand side of this equation. So this is my oxidation process. It's losing 4 electrons. All right, so that's the balanced half reaction for both atoms and charge. Now I'm going to do the same thing for this one down here. I've got NO3 with a negative charge here, and I have NO here. So the first thing I need to do is I need to add some oxygen or add some water to make the water equal on both sides. So I'm going to add 2 H2Os to this side. So now I've got 3 O's on this side, and I have 3 O's on that side. Now I need to balance the hydrogens with H pluses. So there are 4 H's in this, so I'm going to need to put 4 H pluses on this side. And now I need to balance the electrons. Well, or I need to balance the charge with electrons. The total charge on the left here is +3. I've got +4 and -1. On the right, it's electrically neutral. So that means I need 3 electrons on that side. All right. Now, in the last one, we had 2 electrons given off and 2 electrons gained, so we didn't have to do anything with that. But in this one, we have 4 electrons lost and 3 electrons gained. I have to make the electrons lost and the electrons gained the same. So I have to multiply through this equation by 3. And I have to multiply through this equation by 4 in order to make the electrons lost and the electrons gained the same. So I'm just going to multiply through this top equation by 3, and then I'm going to multiply through this bottom equation by 4 before I add them together. So multiplying through this one by 3, I end up with 15 H2Os plus 3 AS2O3 goes to 6 H3ASO4 plus 12 H pluses, the number is getting kind of big here, plus 12 electrons. If I multiply through this bottom one by 4, I get 12 electrons plus 4 times 4 is 16 H pluses plus 4 NO3 minuses yields 4 NOs plus 8 H2Os. So now the electrons gained and the electrons lost are equal. I should be able to add these together. But before I add them together, I can cancel some stuff. I've got 12 electrons lost here and 12 electrons gained there. That cancels. I've got water on both sides. I have 8 water molecules here and I have 15 here. So I can take 8 water molecules off of both sides and I can say that's going to end up being 7. I also have 12 H pluses here and 16 H pluses here. So I can take 12 H pluses off of both of these and we can say that that's going to be a 4. Now, if I've done everything right, I should be able to gather everything up on both sides and it should be balanced for both atoms and charge. And I end up with 7 waters plus 3 AS2O3s plus 4 H pluses plus 4 NO3 minuses yields 6H3AsO4 plus 4 NO, and that's it. All right, now you should check and make sure that this is balanced for both charge and atoms. And I'll let you do that on your own, but if you confirm, count everything carefully, you should see that the number of atoms of everything is the same on both sides, and it's balanced for charge. All right, so that's the first two. The first one was a little easier. The second one was a little bit harder. See what you can do with numbers 3, 4, 5, and 6.